Here comes Longo with a video on midsegments of a triangle. So to begin, what's a midsegment? Well, a midsegment is created by two midpoints. So we're just going to draw one over here. We're going to cut this side of 10 in half. That'll be 5 and 5. And then we're going to go cut this side in half. And that's going to become 6 and 6. So a midsegment is when you connect those two midpoints. And what it does is it creates two different properties you need to know. The first thing, it's going to be half the length of the third side. So if we know that this bottom is 14, then this is going to be 7. So it's going to be half the length of the side not using one of the midpoints. And the other thing, it's going to be parallel to that third side. So that red line is going to be parallel to the length of 14. Okay? So those are the two properties that come out of a midsegment of a triangle. So we're going to start by doing 3 examples. And there's a couple of different ways you can look at these. The first one is really simple to just think about and say, oh yeah, x is going to be 10. But when you get to algebra, think about this. Is it easier to multiply by 2, or is it easier to take half of something? Well, that really depends on, if it's even or odd. So a lot of times if you have an odd number, then you have to deal with fractions. So a lot of times algebraically, it's easier to say 2 times the midsegment is equal to that third side. So we'll just say it's the third side. So to do this one, again, like I said, x is 10. But algebraically, it might be easier to say that 2x is equal to 20. So you can just say x is equal to 10. And the reason why is for example number 2. When you get to example number 2, it's easier, in my opinion, to say that 2 times your midsegment is equal to that third side, because then you're not going to be dealing with fractions. If you decided to set this equal to half of the third side, then you would be dealing with 3/2 x minus 6. So if you like fractions, go right ahead and do it. Otherwise, it's easier to just double the midsegment and set it equal to that third side. So then you're just going to have 2x plus 8 is equal to 3x minus 12, which will give you x is equal to 20. Using the other property, when you have a midsegment, they are parallel to that third side. So this is going to take you back to corresponding angles and same side interior angles and stuff like that. So if you look at angle 1, it's on the same side, both interior. If we were to go back and sketch this little graph, 40 is down here. Angle 1 is right here. Those are same side interior angles. So angle 1 is going to have to be 140 degrees because same side interior angles were always supplementary. But then when we get to angle 2, if we were to just sketch this out on a full scale, angle 2 is right here and angle 60 is right there. So they're both on the same side of the transversal, but 60 is an exterior angle. So this is an example of corresponding angles because it's the top left of the intersection and top left of the intersection, which means angle 2 is a corresponding angle, which means it's 60 degrees. Okay, so that's how some of your old school topics are going to play into this topic of midsegments. Now we're going to take it 2 steps further. And I mean 2 steps is because we're now going to join 3 midsegments of a triangle and create what's known as a midsegment triangle. So if I were to tell you that M, N, and O were all midpoints, then you know that AM is congruent to MB because it cuts a segment in half. Same with AN and NC, and same with BO and OC. So what we did is we just took 3 midsegments and connected them all together, and it creates this midsegment triangle. But all those properties still exist. It just means we have more work to do. So in this problem, if we're given that AB is 8 BC is 11, and AC is 6, we can find all of those midsegments. MN is half the length of the segment it's parallel to, so MN is half of 11, which is going to be 5.5. NO is going to be half of the segment it's parallel to, which is 8, so NO is going to be 4. And MO is going to be half of 6, so MO is going to be 3. So just by knowing the properties of a midsegment, finding the lengths of all the sides of a midsegment triangle is not much more difficult. It's just you have to find the length 3 different times. And that's it for that guy. Now, when you take it to corresponding angles and stuff like that, really, after you find all 3 angles of one triangle, you'll notice there's a shortcut, because what it's going to do is create 4 congruent triangles. So we know that this is 40. We know that this angle right here is 60 degrees, which means its corresponding angle will also be 60 degrees. And then from there, we're going to look at a triangle. We know all angles of a triangle will add up to 180 degrees, so 40 plus 60 is 100, meaning we're missing 80 degrees, which means that this guy is corresponding is also 80 degrees. But now we get to take it a step further. We know that this segment right here is parallel to this segment right here, so that means the corresponding angles don't only work vertically, they also work going horizontally. So this angle right here is corresponding with this angle, which is 80. And this angle right here is 40, which is corresponding with this angle, so that guy's 40. So as you can see, all 3 of these triangles that are, shall we say, pointing upwards, are going to have the exact same measures in all of the exact same places because of corresponding angles, corresponding angles. And then what happens to the one on the inside is they just get flipped due to alternate interior angles. So if you were to look at 60 here, it's alternate interior with this guy right here. So that guy is going to be 60. And alternate interior angles will tell you that this angle is 80. And of course, triangles always add up to 180 degrees. So even though 40 and this angle don't have any relationship of their own, triangles always have to add up to 180 degrees. So the inside of this guy is also going to be 40. So that's it. So again, midsegments, they're half the length of the third side and parallel to it, which means it's going to create a lot of lengths that are half of the original length of the triangle, and it's also going to create a lot of congruent and supplementary angles due to same side interior and alternate interior and corresponding angles. All right, that's it for midsegments and midsegment triangles. This is Longo, and I'm out. See you, bye.